It is designed for the most dangerous missions, to support ground troops and destroy their enemies. Its name? The Tiger, an attack helicopter with unique striking abilities. Jointly developed by France and Germany, the Tiger helicopter has become one of the jewels of the French Army light aviation.
This is a weapon system that has been designed and the machine built around it afterwards.
Employed in numerous external operations since coming into service in 2009, this war machine has become indispensable for gaining the upper hand.
Today we are frequently in a struggle against terrorists, meaning people who hide, are difficult to catch, who are on the run. I have units progressing southwards.
Thanks to exclusive images, declassified by the Army and captured during combat missions, to computer graphics, and to pilot testimonies, you will embark on one of the most sophisticated weapon systems in its category.
The Tiger has proved to be the combat helicopter capable of going very far, very quickly, and hitting very hard.
You will discover the production secrets of this exceptional machine.
Let me show you the guts of the Tiger.
When you look head-on at a Tiger, it's like looking at a Formula One.
And see how pilots manage to come through the most dangerous situations.
It's firing. Helicopter to the side. Coming from the left.
900 meters, affirmative.
Agility, stealth, firepower. Welcome aboard the Tiger combat helicopter. "50 kilometers from Strasbourg, the La Roye camp is an army base unlike the rest. Here, there are no tanks, no heavy-duty trucks, but helicopters. They belong to the ALAT, the French Army Light Aviation, or more precisely, to the 1st RHC, the 1st Combat Helicopter Regiment. In the hangars which line the runway, a new type of machine is concealed. An exceptional apparatus, the EC-665 helicopter. Codename, Tiger. Like the big cat from which it takes its name, the Tiger is an intimidating machine. 14 meters in length, 4 meters high. Equipped with a tandem seat cockpit, comprising a low-position station for the pilot and a higher one for the pilot in command, this is one of the elite class of attack helicopters. Fitted with night and day vision cameras, it carries the widest range of weapons in the world for its category. Its 2 engines allow the helicopter to travel at speeds of up to 275 kilometers per hour. A phenomenally powerful war machine.
We can intensify the exercises, putting in a lot of tactical aspects.
What scenario are you looking at?
A classic one for the moment, like Mali.
Colonel Pierre heads the operations division at the ALAT. He has received the highest military distinctions for his deeds in the field of combat. Beside him, Lieutenant Colonel Cyril commands the Reconnaissance and Attack Helicopter Battalion of the 1st RHC. He was the first person to pilot a Tiger helicopter during operations.
Perfect. The operational life of the Tiger began in the spring of 2009 in Afghanistan, in the Kapisa Valley. The ALAT was taking delivery of this Tiger. At the time, it had 2 of them. As soon as they were deployed, they showed themselves to be absolutely indispensable, to the point of becoming what we call a no-go criterion, meaning that when High Command launched an operation, if they weren't sure of having Tigers available, the operation was off. They knew that this helicopter was capable of providing tangible superiority in the field against the Taliban, who we were fighting at the time.
In the mountains of Afghanistan, the Tiger immediately proved its exceptional maneuverability and stealth capacities, essential in a combat helicopter.
The principal stealth advantage in the French Army light aviation is being hidden in the landscape. We work on the principle of flying it between 0 and 10 meters from the ground and being highly maneuverable. This maneuverability makes you extremely reactive and allows the crew to place the machine in the best configurations for a successful mission. In the space of a few seconds, we can take the helicopter from a high-up fixed position to rapid ground-level operation and to carry things through with complete freedom of movement. This means we can concentrate on the tactical dimension because we know that the machine will cope with just about anything. You have no problems of power with the Tiger.
Since 2009, Tiger helicopters have been deployed in virtually all the French Army's theaters of operations, notably in the Middle East and in Africa, Afghanistan, Libya, the Central African Republic, and Mali. The helicopter has been used everywhere to terrorize the enemy and has proved to be adapted to all types of threats.
Today we are frequently in a struggle against terrorists, meaning people who hide, are difficult to catch, who are on the run and who operate over vast areas. The Tiger has this capacity for projection and getting up close to the enemy. Today when you deploy a helicopter into the field, people know about it. A helicopter allows you to leave very quickly and go a long way. A bit like a big cat. You never know where it is. You just know it's creeping around and could pounce on you. It allows you to turn the balance of power around and fear changes sides. When a helicopter goes into action, the psychological factor and the fear of being struck shifts sides. People become very wary.
The agility of the Tiger makes it one of the few helicopters in the world to be able to carry out a loop. This sort of in-flight prowess is due to the helicopter being designed to be as light and as powerful as possible. It's in France, in the town of Marignane, 20 kilometers from Marseille, that the French EC-665 Tiger is built.
To allow us to arrive at a machine which is agile and light, we chose composite materials which have the advantage of being a lot lighter than metal. The composite materials are of three principal types: carbon, Kevlar, and fiberglass. It's a sort of meshwork, fiberglass fabric, onto which we apply several coats of resin, which give the structure its rigidity and also give it much greater resistance than a metallic structure. Composite materials give structural rigidity when a machine has to react like the Tiger does. The pilot has to cope with several Gs, and so does the machine. With composite materials, you have the necessary rigidity.
The central part of the helicopter, which suffers torsion during flight, is a composite made up of a light honeycomb structure, sandwiched between two skins which provide both resistance and the capacity for deformation. For the upper sections, a carbon monolith was chosen to resist the high engine temperatures. And for the blades, a mixture of fiberglass and carbon over a polymer base give them both suppleness and strength. Lastly, the pilot's seats are of Kevlar and boron carbon, an extremely hard ceramic capable of resisting enemy machine gun bullets. Thanks to composite materials, the mass of the helicopter is reduced to 6.5 tons, 15% less than its American rival and 30% less than the Russian. But its lightness is not the only characteristic responsible for the Tiger's agility. The machine is also equipped with engines specially adapted for aerial combat missions.
The Tigre attack helicopter has a unique power-to-weight ratio. This is thanks to the engines, which were chosen for the Tigre, NTR 390E engines. The advantage of these power units is that they are very compact and deliver a huge amount of power for their size. Each engine delivers 1,500 horsepower, that is to say 3,000 horsepower when it's running on two engines. But another advantage with this machine is that it can fly on one engine. If there's a breakdown or if one engine is damaged, the helicopter can still fly and leave the operation zone safely. There's another particularity in the positioning of the two engines. There is armor plating separating the left engine from the right, and this mutually protects the two engines should one of them explode. This motorization allows the fully equipped helicopter to reach speeds of around 146 knots, or about 275 kilometers an hour.
In the workshops of the Airbus factory, several hundred people work on the construction of this unique helicopter. Because of its extreme complexity, nothing can be automated. Each unit is assembled by the expert hands of the technicians and workers.
Each operative is pivotal to the assembly operation. Each action requires particular skills and particular know-how. The Tigre, in terms of complexity, is a piece of high technology. It's like doing the work of a goldsmith or building a flying Formula One. The avionics systems are also very complex and precise, as are the armament systems. Tigers aren't produced in thousands or tens of thousands per year. The quantities are quite limited, so each one is very special and is closely followed throughout the assembly phases. We know these Tigers right up until they're delivered.
Between the initial sketches and the first test flight, 20 years of work went into this machine. An attack helicopter capable of carrying out the most spectacular maneuvers in order to attack its enemies. This is the GAMSTAT, the Air Mobility Group of the Army's technical section. This is where tests are carried out on the key element of the Tigre, its weapons.
It's one of the first times that a weapon system has been designed and the machine built around it afterwards. The Tigre was conceived as a complete arms system. They said, this is the effect we want to achieve. That's to say, an armament system which covers everything with a helicopter built around it.
Before being authorized for operational use, the weapons which equip each unit have to pass through the hands of the test pilots. Electronic systems and equipment, everything is verified by the mechanics and pilots. Because one of the principal advantages of the Tigre is the ability to adapt its armaments depending upon the type of mission. Lieutenant Colonel Jean Mathieu is head of the Tigre test program at the GAMSTAT.
Here you have the stub wing with an inner station release unit and an outer station release unit. Beneath each of them you can put a certain amount of material. At the moment we have a 22-barrel PLR, that is to say 22-shot rocket pods, in which we can load 68mm rockets of different types depending upon operational necessity. The range of this type of armament is about 4 kilometers. We can have smoke rockets, anti-vehicle or anti-personnel rockets. The crew chooses the type of rockets needed in relation to the type of mission to give the greatest versatility. Beneath the outer release units, we have two Mistrals, which are air-to-air missiles intended to destroy other aircraft, be it helicopters, fighters, or slow aircraft. These have a range of around 5 to 6 kilometers. These are fire-and-forget missiles with infrared tracking. Once they're locked onto the target, the missile launches and the pilot has nothing more to do. The missile is autonomous.
On the other side of the helicopter is a new generation weapon, the first operational usage of which has only just been carried out by French forces.
Tigre in firing domain. Confirm firing authorization.
The Hellfire missile.
Firing authorized. Disengage.
It's an air-to-ground missile employed against armoured vehicles as well as fortified buildings, such as bunkers. It has a range of up to 7 or 8 kilometers according to conditions and includes a laser seeker which can lock onto a laser spot emitted by the helicopter itself or by another unit or even by ground troops. It should be appreciated that during combat the object is to fire from as far away as possible in order to avoid enemy fire. Obviously, if you can fire at something from 6 or 8 kilometers, when you're out of range and out of sight of the enemy, this is preferable because it's less dangerous for the crew than being up close. The missile launches, follows its upward trajectory, and at one point its tracker homes in on the laser spot which is emitted by ground personnel, for example, who can see the target but are themselves totally hidden and protected by the undergrowth.
In addition to the armaments connected to the release units on each side of the machine, the Tiger has a weapon of major strategic importance during combat. It is principally used for assisting maneuvers of ground troops or destroying an enemy at short range. The 30mm cannon.
Let me show you the guts of the Tiger. So, here you have the ammunition magazines. There are 4 magazines, each carrying 90 30mm shells. How does this work? They follow a path inside the machine, about where my hand is, eventually arriving at the cannon bolt. This is a turreted 30mm cannon. What does turreted mean? It means the cannon can scan everything in front of the helicopter, both in elevation and bearing. Elevation, meaning that it can pan up and down without the helicopter moving, and bearing, meaning that it can destroy targets which are not directly in front. Some weapons have a fixed position, which is not always practical, because the aircraft has to be maneuvered in order to take aim. Whereas here you can scan the whole sector in front of the helicopter to destroy any target. This 30mm cannon can fire different types of munitions. They may be explosive shells or incendiary shells, fired with great precision up to a range of around 1,500 to 2,500 meters. This is for all types of ground objectives, be they personnel or lightly armored vehicles.
For external operations, the Tiger is sent with its entire arsenal available.
Combat is an inexact science with many unknowns, and we never know precisely what enemy we will come across. The advantage with the Tiger is that with all its armament systems in tow, we can react to any situation. In the French Army light aviation, we have what we call cockpit delegation, which means that it's the pilot in command who decides what type of armaments need to be used to carry out the mission. There are several phases, and their goal is protection. During the combat phases, we always favor a distant approach over a close one. So the use of missiles like the Hellfire allow us to keep our distance. Next, we need to consider the nature of the enemy. If you're dealing with a pickup or a building, a 30mm cannon shell isn't ideal. Not always in any case, so we tend to go for a missile. When you have a zone which is heavily wooded, very spread out, which implies covering a wide area, we generally choose a rocket. However, when we're up close, we use the 30mm cannon, which gives extremely precise fire. Basically, at 2,000 meters or closer, 1 to 5 shells allows you to achieve the required effect on the enemy. In certain situations, the crew uses the whole range of armaments to deal with the threat at hand.
During operations, the commander chooses the optimal armament configuration, taking into account the mission, the enemy, and the targets to be destroyed. For long-distance missions, the machine can be equipped with additional fuel tanks, which give the Tiger an exceptional radius of action for an attack helicopter.
These days, we sometimes add extra fuel tanks to the Tigers, which can give you up to 5 hours of autonomy. So these helicopters can leave for a very long time and go a very long way. The radio is capable of keeping you informed of what's going on, and during the raids we went on in Mali, sometimes right up to the Algerian border, the Tiger proved to be the combat helicopter capable of going very far, very quickly, and hitting very hard. It was also able to return to the base without intermediate refueling, which can be extremely debilitating and dangerous to organize logistically and tactically.
But the Tiger's armaments would be useless without its targeting system to localize and fix its objectives. The first key element of this system is simply the pilot's helmet. It bears the name Top Owl, and each of them costs nearly 150,000 euros.
The Top Owl helmet consists of two main parts. This part called the BH, for basic helmet, and inside it a part which is precisely molded to the head of the pilot, adapted to their specific morphology. The standard shell is outside, and onto it this display module is fixed. The display module has different visors. There's a smoked visor, which we see here, which protects us from the sun. And beneath this, there's a clear visor. All necessary information about piloting, navigation, and the weapon system is projected onto this clear visor in front of the pilot's eyes, so that he can carry out the mission without looking towards the interior of the helicopter. The helmet is perfectly molded to the head of the pilot so that firing can be as precise as possible. What is projected in front of the pilot isn't just symbols, this is an essential part of the firing process. This is how he takes aim. So alignment between the eye of the pilot, what is projected in front of him, and the target needs to be perfect. Hence the need for this personalized molding according to each pilot's morphology.
The helmet is also made for both day and night use. Because it's at night where the vast majority of Tiger's missions take place.
For the moment, the zone is still clear. No movement in the proximity.
To change it to nighttime configuration, I remove the prisms you see here and replace them with the light intensification system, which is positioned like this on either side of the helmet, which gives the pilot a light intensified image, projected directly onto the clear visor inside the same helmet. It's basically a passive system which captures the slightest amount of light, the least little photons in the pilot's field of vision. They enter these tubes, are electronically amplified, and are projected onto the pilot's clear visor. Just like an animal, in the depths of the night, he can see almost as well as in daylight.
Once seated in the cockpit, the pilot plugs the helmet into the helicopter's electronic systems. the pilot has now become an integral part of the machine. The forward cannon movements are slaved to his head, as if the weapon was the extension of his eyes. The cannon automatically follows the movements of the pilot's head in order to engage in combat within a fraction of a second. In addition to the pilot's helmet-mounted sight system, the helicopter is equipped with another high-technology sight, the Strix.
It's equipped with different channels, a TV channel, a thermographic channel, but also a laser rangefinder to give you the distance and allow you to select armaments. Images from the sight are projected onto the screens in front of me.
We have a pickup at 2 kilometers with a gunner heading towards our 6 o'clock.
These images were taken during an anti-terrorist reconnaissance operation in Africa. They were filmed at a distance of more than 1,500 meters.
We're going to take a look at it.
The camera of the Strix can zoom in close on the scene while the helicopter keeps its distance from the enemy.
It's still the same zone, close to the intersection.
At night, the thermal camera reveals the slightest source of heat in the environment.
The pilot in command and the pilot have images in mind, what we call their image bank, and can recognize the shape of a foot soldier with a machine gun hiding in a ditch, or the shape of a pickup hidden under a tarpaulin in the undergrowth. They know these shapes, and if there's any doubt, they can zoom in on the zone for more precision. Once they have what we call PID, meaning positive identification, and the chain of command has given authorization, they can open fire.
We're good. They've come to a halt. Commencing firing. Okay, no adjustment. A crocodile. Fire. Direct hit.
For the crew of the Tiger, it's the pilot in command, seated behind, who directs the mission, also known as the gunner. He's the one who handles the helicopter's armament system.
When you're sitting in the back seat, you have the same flight controls as the pilot. This means that if there's a problem, you can take the controls at any moment. Added to which, you have screens in front of you giving all the flight data to supplement what is in the helmet. That's the basic piloting. In addition to all that, we can also control the weapon systems thanks to these 2 grips, with a variety of buttons which also control the main sight, which is just above my head. As you can see, each of these buttons has various positions which allow you to change the sight's field of vision, to change its zoom, etc. And finally, I can fire my weapon by pushing on this hidden button marked in red. For selecting the armaments, I have a box with a certain number of buttons, which not only allows me to choose a weapon, but also to change its parameters. For the rockets, I can choose which type. For the cannon, I can choose the length of burst. The Hellfire and Mistral missiles have a whole range of settings which I can control from this box.
The cockpit is extremely narrow with everything immediately to hand. Ergonomically, it's very well thought out and quite natural. Obviously, it takes a lot of training to be able to find each of the 20 or 30 functions on each grip at night without looking. This has to come naturally, which requires training. But when you're sitting here, you feel at one with the machine.
During a mission, the pilot and the pilot in command are in constant communication by radio and must both be able to negotiate the environment through which they're traveling at any moment.
In principle, the screens are low down, so we're permanently looking around and only glancing at the screen, which theoretically simply confirms what we see outside or gives precisions about what we're looking for. In any case, both crew members are never what we call inside at the same time. That's the first rule. When one is inside, he says, "I'm inside," and the other replies, "I'm outside." You're never both inside at the same time. You have everything in the helmet. Information about velocity, headings, tracking, firing, about which weapon will be used, if it's locked in or not, if it's ready or not. So the forward pilot doesn't need to stay inside because all the necessary parameters are in the helmet. Behind, the pilot in command is effectively more concentrated on the armament and flight systems than the pilot. He's in charge of navigation, of the radios, and these things need an amount of input, so he often has his head inside. But even though he's less outside than the pilot, he needs to keep taking a look because he's the one giving orders and determining where to go.
When they arrive in a combat zone, the pilots exploit all the capacities of the machine to gain advantage over their adversaries.
The first thing you look for during combat is protection, and then somewhere to fire from. So when the crew arrives on the scene, they try to find the best place from which to fight. Having found this, they can scan the entire area with the cameras. If it's nighttime, they can use the thermal camera to spot anything that's moving, or which stands out from the natural environment because it's much warmer. These things appear much greener, much more intense. During the day, you're looking for things which are highly mobile. From there, you can focus in from wide shot to close-up to pinpoint the enemy. You generally find them.
It's a question of spotting your allies, spotting your enemy, and defining operational procedure. For example, I may have the enemy in my sights, and I tell the pilot that we're going to proceed in such a fashion, begin and end firing in this and that position, when to withdraw. And perhaps during withdrawal, the pilot in command will tell the pilot to maintain sightings so that the enemy remains targeted, whatever the helicopter's movements may be. It's real teamwork.
Meanwhile, back at the Falsburg base, the pilots of the 1st Combat Helicopter Regiment are preparing to leave for an exercise under real conditions. The mission: to escort an NH-90 Cayman helicopter during the exfiltration of commandos from enemy territory. In the briefing room, the pilot in command and his pilot look over the flight plan together. They review the frequently rehearsed actions which pilots go through before a mission. Putting on the bulletproof vest, indispensable given the helicopter's proximity with the ground. Preparation of the helmet and its sight module. Then, off to the runway for final checks on the helicopter.
We're off. No wind. It should go well.
On the tarmac, the Cayman, then the Tiger take off. Each action is coordinated between the two helicopters to the second. Direction: the zone from where the commandos need to be exfiltrated.
70 knots is good. Maintain that. Stay to the right to leave room for the Cayman.
The two helicopters fly in formation, the Tiger above the Cayman.
This is probably the Voltag sector. From here, this looks like it. Continue. It opens up over there. It's over there.
Having arrived at the zone, the Cayman lands in a clearing designated as the pickup point for the commandos. The Tiger crew takes up position above the exfiltration zone, looking out for potential enemies, while the pilot maintains stability above the clearing. The pilot in command uses the helicopter's strict sight to secure the zone and zoom in on any hiding places from which an ambush could come. With the Strix's thermal camera, the commandos can be clearly seen in the forest. They will remain undercover during the security screening carried out by the crew of the Tiger and wait for the green light from the pilots before approaching the helicopter. As soon as the Tiger has secured the zone, the commandos are authorized to climb aboard the Cayman. In total, the exfiltration operation lasted barely 4 minutes. Pilots train in this type of mission because it's a situation which frequently presents itself in conflict zones. During these few minutes of exfiltration, the crews of the 2 helicopters need to remain extremely vigilant because they could be ambushed at any moment.
Okay, survey everything below.
These images were captured by the Strix site of a Tiger helicopter carrying out an identical exfiltration operation during the war in Afghanistan. Initially, everything goes to plan. In the cockpit, the crew, positioned above the commando's exfiltration helicopter, observe the operation from a distance. In these images, the infrared signatures of the soldiers proceeding toward the helicopter can be seen.
Okay, visual of the packs heading towards him. They're behind the rock, we're good.
When suddenly,
There's firing, there's firing. Where? Helicopter to the side. Coming from the left.
I've lost frequency with Marty.
Stable, stable. Stable on the point of fire.
Got it. Okay, range.
250.
I have a visual on a guy.
These days, the biggest threat isn't a high-technology missile. It's a small, roughly guided missile, or a rocket launched because we'd landed somewhere and they thought they might fire at us. Generally speaking, we detect a missile after it's launched. We detect the firing. Something's been let off, but we don't know where.
Range. Released.
When you're attacked suddenly, you have to act extremely quickly.
It's going. Still stable. Impact.
When we're suddenly attacked, there are 2 types of action. Firstly, the pilot makes an evasion maneuver, which means handling the machine extremely brutally and solicits everything mechanical. At the same time, there's a firing maneuver where the pilot, thanks to his helmet, aims the cannon and open fires on the objective from where the attack is coming. It's a question of survival. These are virtually reflex actions. The evasion maneuver takes the pilot a few tenths of a second. The firing action takes less than a second because the objective is to immediately detect and neutralize the attacking target. So these 2 actions are extremely brutal and extremely rapid for the crew's survival and the completion of the mission.
that day, in the mountains of Afghanistan, the 2 helicopters escaped the attack unscathed. But these images show to what point the Tiger is under permanent threat from the enemy. This is why the engineers designed it to be the least vulnerable possible. First, by placing the pilot and the gunner, one behind the other, the designers managed to obtain one of the narrowest attack helicopters in its category.
The choice of a tandem seat cockpit is principally a question of discretion. When you look head-on at a Tiger, it's like looking at a Formula One. Nothing sticks out at cockpit level. This means it presents a very limited target area compared to helicopters where the crew sits side by side and are a larger target. So that was the first element, providing discretion and limiting the exposure of the crew when threatened by an enemy.
During a mission, a helicopter can be detected by enemy radar on the ground or aboard aircraft.
Radar are active systems designed to detect a target. They basically function by emitting an electromagnetic wave, which, when it arrives at a target, is re-emitted in various directions. The part of this energy which returns to the radar is captured and analyzed, allowing the radar to localize the target.
The Tiger was specifically designed to make it as undetectable as possible.
A radar can only detect a target if part of the energy which it previously emitted comes back to it. Faced with these electromagnetic waves, we do whatever we can to make the shape of the fuselage re-emit this energy in directions other than where the threat is coming from, outside the radar zone. With regards to the Tiger, we worked on the concept of stealth in terms of shape, based partly on this extremely narrow front cross-section, associated with flat side panels. This means that, viewed from a very wide front angle, it produces a very weak radar signature, and in addition, it bounces this energy back into less threatening sectors.
As well as its shape, the materials used for the fuselage have the capacity for absorption and deviation of radar waves, which allow it to send back only a minute quantity of the waves received. But the Tiger's stealth in the face of radio waves is not sufficient by itself, because like all hot objects, a helicopter emits infrared rays which can be picked up by enemy equipment. And once the infrared signature of an aircraft is detected, a missile can be sent to take it down. During its flight, the missile only has to lock its trajectory onto the infrared rays of its target in order to reach it and destroy it.
The detectability of a helicopter is directly related to its infrared signature. The higher up it is, the further away it can be detected, and the easier it is for a missile to track it. The principal contributor to the infrared signature of an aircraft are its hot and very hot zones, so we try to reduce them. The first method is with infrared suppressors, which are placed aft of the piping and make it possible to dilute and deviate the airflow coming from the engines to make the hot zones cooler and smaller. Then we have a second method which is incorporated into the paint. We have what are called low emissivity paints, which at a given temperature emit less infrared than a fuselage not coated with it.
But faced with certain detection devices, radar and infrared stealth are insufficient. The helicopter is therefore equipped with what is known as its self-protection system, which responds to this threat. Front and rear radar detectors sweep 360 degrees around the helicopter. In the nose and under the tail, missile launch detectors pick up, within a radius of several kilometers, the ultraviolet plume of a missile at the moment of launching. At the tip of each stub wing, the Tiger has laser detectors, because certain missile systems use laser technology to identify a target before striking it.
Stealth allows the helicopter to delay the moment of its detection for as long as possible. If, despite this, the helicopter should come under threat, thanks to its self-protection systems, the crew is warned about this threat, and whether it's in the form of radar, laser, or a missile launch. The countermeasure system is automatically activated in an attempt to decoy the approaching threat. With regards to radar, the decoys are mainly based on a system of electromagnetic metallic particles. The basic principle is to eject a certain amount of this chaff, which reflects the incoming waves and creates a sort of cloud screen for the radar, thereby preventing it from identifying the exact position of the helicopter.
We can tell whether it's a pursuit radar or a detection radar. If it's a detection radar, we know we've been spotted. If it's a pursuit radar, we'll soon be under fire. It's a similar logic to when you have a dog with its teeth in the seat of your trousers. You need to get it off. When you're in the field, there are only a certain number of solutions. Either you can deal with the threat, so you reposition yourself and try to gain the element of surprise. That's a bit of a cat and mouse approach. Or, if you're not able to deal with it because of its magnitude, then you have to go for evasive action and head for an exfiltration route. This is either a path which you've picked out beforehand because you are on a quick strike and return mission, or it's a path which you create for yourself with tactical flight. You can hear the sound of a low-flying helicopter, but it's impossible to tell exactly where it's coming from. Up until the last moment, it's at treetop level. It's hidden by the relief. It's behind the line of hilltops. Only the top of it might be sticking out, but the rest of the machine is at hilltop level. It doesn't need to come out, it never shows itself. So these are the trajectories which you use for exfiltration. You go away or you re-attack from a different angle, constantly hugging the landscape. This is what gives the helicopter an advantage over the aeroplane. You can stop, consider, move back, advance, climb, descend. It's the ideal vector for combat, up close and discreet.
In the event of enemy missile fire, the Tiger is also equipped with a decoy system. Flares are ejected at the approach of the missile, which is attracted by the heat of these decoys and is deviated from its target. This system proved its efficiency on the second operational mission of the Tiger in 2011, during Operation Harmattan in Libya.
After Afghanistan, the Tiger found itself in an unfamiliar environment, which it discovered a bit like everyone else. It found itself out at sea, in the middle of the night, up against a much more powerful enemy than it had faced in Afghanistan. An enemy equipped with ground-to-air missiles, with an enormous quantity of anti-aircraft material. It was on this occasion, June 4th, 2011, that Tiger helicopters came under ground-to-air missile fire. It was the first time, and I distinctly remember seeing the decoys set off all over the place from the helicopters in the pitch black. And then seeing the missile lose its objective and fall into the sea, chasing after the decoys of the Tiger.
Today, the Tigers of the French Army Light Aviation are mobilized as soon as France engages its forces in a theater of operation. In addition to the French Army, the Tiger also equips the German Army with a slightly different version, which has a sight placed above the helicopter, making it possible to observe the enemy while remaining out of sight. Collaboration between the two countries, which began at the initial conception stage, has also led to the creation of a joint flying school. All Tiger pilots from the two nations train at the EFA, the Franco-German school situated in the south of France. The Tiger also equips the Spanish and Australian armies. With literally thousands of combat missions under their belts, Tiger helicopters are today amongst the most respected by the armies of the world.
When the two pilots take off with their helicopter, when several of them leave on a mission, it's really a pack setting off. These are hunters going off to ferret around, sometimes in the desert, sometimes in the mountains, sometimes in the jungle. They're off to seek out their prey, and like big cats, the Tigers have capabilities and senses developed through technology. And when they work in perfect symbiosis with the instincts of the pilots, the results are incredibly efficient. Today they allow us to be counted amongst the fighting nations. The Tiger is a veritable guardian angel, providing operations with unlimited surveillance, mission observation, reconnaissance, and destruction capabilities.
Today, engineers are working in collaboration with the military to even further improve the capabilities of this extraordinary helicopter. An even higher performance sight system, an even more precise cannon, even more destructive missiles. The Tiger of tomorrow will undoubtedly inspire even more fear in its enemies.